So having said that, let's kick off with our lesson for this evening, which is on finding the equation of a tangent. So now we are absolute masters of differentiation because we cracked the differentiation on Tuesday. And if you're not a master yet, don't worry about it because we are going to practice differentiation throughout. As I was saying, also have your pen, paper, calculator ready with you. Work with us as we go through all the examples and try as well to try all the questions. Okay, don't be scared to try. Okay, so this evening we're going to look at the equation of a tangent, and it's really sort of the first application of the derivative that we are going to start exploring. For those of you who have done calculus at school, you know what comes after this is cubic graph sketching, which is also a really fun sort of application of the derivative and calculus, and just drawing this new graph that you guys have never done before with 2 turning points and 3 intercepts. So that's kind of like your level up in metric. And then but this is like the first step. So if you think of the derivative and you think of everything you do, yes, that's cubic graph. So everything we've done, I'm just going to glance back over our lesson so far. We started off just with a little bit of stuff on limits, and then we looked at the first principles and the average gradient. And remember, we said that when we differentiate, when we find the derivative gives us an equation to calculate the gradient at a point. So if you understand that that is what calculus is, then you are well on your way to understanding calculus. Okay, so the derivative is another word for the gradient. And the derivative, all that differentiation we did the other day when we started here in lesson 2 with all this differentiation, all this gives us is an equation that can help you calculate the gradient at any point. We also, remember, started off calculus talking about average gradient and instantaneous gradient. So instantaneous gradient is the derivative at a point on a graph, not just between 2 points, that is the average gradient, but at a specific point on a graph. It's a tool that we have by differentiating our function, that expression we get, that's going to help us find the gradient at a point, and in turn find the tangent, the equation of a tangent. So you would have heard the word tangent before, because tangent we also did when we did circles. Skako, do you remember the equation of a tangent when we did analytical geometry, and we did the tangent to the circle with the gradient and the perpendicular, all of that stuff. So you should know already what a tangent is. It's a straight line that touches a curve at a specific point. So so right now we kind of have to have that in the back of our minds. We have to understand what the derivative is, how we get the derivative, and what the derivative means. And those are sort of the 2 concepts that we need as we start off finding the equation of a tangent. Okay, so if we want to calculate the gradient at a point, we find the derivative. So we take our function, we derive it, we differentiate it, and we substitute the value of x, like so. Okay, so here is an example. Find the gradient of f of x equal to minus 2x squared plus 8x plus 24 at each of the following points. Okay, so we can see that this is a quadratic function, so it's parabola. And if we want to find the gradient at a point, we need to find the derivative and substitute in the point. So what I want each of you to do now as we warm up is find the derivative of this function. In other words, differentiate it. You can do it quickly there on your piece of paper in about a minute, and post your answer in the chats. Let's see if all that differentiation we did in our last lesson has paid off. Tava was quick, very quick. Excellent. Well done. Okay, good stuff. I'm getting lots of answers. I want each and every person to try. Okay, so even if you're not posting, I hope you've got it there with you. We're going to go 2 times the minus 2 gives me minus 4. X, subtract a 1 from the 2 when we differentiate, so that will be x to the power of 1. We don't have to write that. Then the power here for the x is 1, so 1 times 8 is going to give me 8. And when we differentiate the 24, that's 0. Okay, awesome. So lots of you got that. Well done. So now we are going to calculate the gradient at point A. So to calculate the gradient at point A, here's our x value. It's minus 1. We are going to substitute that minus 1 into our derivative. Okay, so let's just write down what this is that we just found. We found the derivative. The derivative, this equation, we can use to find the gradient at any point on the graph. And this particular point is minus 1. So we sub in minus 1. And we get 4 plus 8. And that is 12. Okay, so the gradient at this point is going to be 12. Okay, let's do another one. So we got our derivative. It's the same graph, same question. And we said our derivative was minus 4x plus 8. Okay, you do this one now. What is the value of the derivative at point D, where x is equal to 2? You try on your own. Let's see. Post your answer in the chat when you're ready. Well done, everybody. Yes. I agree. I think it's going to be 0. Let's see. Let's check. Let's test. We sub in x equal to 2. And that gives me 0. I think some of you answered really quickly because maybe what you recognized was that this is indeed a turning point. It says here as well. So we know that the gradient at the turning point is always going to be 0. So that is important. Maybe write that down. The gradient at the turning point is always equal to 0 because you are going to need that for cubic graph sketching and for finding the equation of a cubic graph. So gradient at the turning point is equal to 0, and that is always the case. For any graph that has a turning point like the parabola and the cubic, that's always the case. Okay, fabulous. Also, sorry, Ms. Kaka, we forgot to mention, as we just paused there for a second, that today, new Watobians, today is quiz day. So at about 1:45, we will post the link to the quiz, and you can go practice what we have been doing this week in calculus. And remember, it's a low stress quiz. You can try as many times as you want, and you can keep going and, you know, work towards a better result each time. So maybe you do it the first time and you're not happy with your results, you can do it again. Okay, there is a time limit, but there really is enough time for you to do this quiz. And remember, last week we got the 79% average. That was the highest average ever on a quiz. So we have something to live up to this week as well. I hope it goes as well this week as it did last week. So, but don't you worry, we'll give you some more instructions at the time, but it will be in about half an hour or so. Okay, so let's see. Given f of x is equal to minus x squared plus 2x. Now we're going to do the average gradient and the gradient of f of x at x equal to 5. Okay, so now average gradient is what you've been doing all along. If you remember from that very first lesson, we did average gradient as well. You do y2 minus y1 over x2 minus x1. So the point really is here that you need two coordinate points. So the question's given us x equal to 1 and x equal to 5, but we don't have y coordinates. So we're going to need to find the y coordinates first before we can do this. Okay, and I think everyone can try to do that. To find our y coordinate, where x is equal to 1, we need to substitute it in. Try that and put your answer in the chat when you're ready. You don't have to write the whole story out like I am. You can just plug it into your calculator. Post your answer in the chat as soon as you're ready. Maybe people are already working out. Okay, Spiciso, is that the gradient? Is that the average gradient, or is that a y value? Just let us know. Okay, so y is -3 or y is 35. Okay, so let's see. It's going to be -1 plus 2. Is 1. -1 plus 2 is going to give me 1. Just double check your answer, Solomon. The minus is in front of the number that's being squared, so you're not squaring that minus. Very careful, be very careful when you put this into your calculator as well. It's good that we do these things because we can pick up where we are going wrong, okay? So calculator work, put in a minus and a bracket and a 1 and a square. Type it in exactly as it is written. Don't leave out the bracket because your calculator is actually very stupid because it doesn't think for itself, okay? It only does what you tell it to do. So it will square the minus if you put the minus in the wrong place. Okay, Kachelo, looking good there. 1 and -15. Ashura, you as well. Praise. Good stuff. Yeah, we should all be getting 1 and -15. And now we can work out our average gradient, which is y2 minus y1 over x2 minus x1. So this we can call our y1, and this we can call our y2, and this is going to be our x1, and this is going to be our x2. Okay, just make sure that when you eventually, well done, Solomon, you fixed it. When you eventually put this into your formula, that you pair up the x's and the y's correctly, x1 with y1 and x2 with y2. So the pairing up doesn't go funky when you actually put it into the formula. So -15 minus 1, my x2 was 5 minus 1. That gives me negative 16 over 4, and this is minus 4. Good stuff. Good stuff. I see some answers. I see some good answers. Well done. Okay, so now there's the question of finding the gradient. Okay, so what we've just done, be sure you understand, is average gradient. We worked out the gradient between 2 points using our good old y2 minus y1 over x2 minus x1. Now the next question was find the gradient of f of x at x equal to 5. So this is asking for gradient at a particular point. And for that, we need to click now. Okay, I need to derive and substitute in. Okay. So Liam, when we do derivative, anything like that, we must use our derivative notation. Let's use the m for average gradient, and then when we do the gradient at a point, use f dash x. Yeah, f dash x is probably the best one because we're doing what is this called? Function notation. Yeah, let's work in function notation. Cool. I know maths is so detailed, so finicky, but it's good. It teaches you to have attention to detail. Okay, I'm going to do b over here. Let me make a little line here so that I don't confuse things. Okay, so where's my equation? Let's derive first. When we derive, that's the notation we use when we are using function notation, f dash x. Our derivative is going to be minus 2x plus 2. Okay, I hope everyone understands where that came from. If you're not clear, just shout in the chat. Also, you can DM as Coco if you are stuck on anything in particular and you want to ask a question. She is available. She's our teaching assistant. So you're more than welcome to give her a shot. Now we want the gradient at the point where x is equal to 5. So we sub that in, plus 2, and we get negative 8. Wonderful. Okay, good stuff. So important to understand that distinction between the average gradient and the gradient at a point as we go into calculating the equation of a tangent now. Okay, so let's have a look at this. Short explanation, basically stuff that we've just been saying. At the point of contact, the gradient is equal to the derivative. The derivative we get by differentiating, and at the tangent point, the gradient are the same or equal. Okay, so the gradient of the straight line is the same as the derivative at the point of contact. Okay, so quickly, if we go back just to answer Kirsten's question, the minus 2 came from differentiating f of x, this one over here. So we go 2 times the minus 1 gives me minus 2 x to the power of 1 because we subtract 1 from the exponent. Okay. Now, if you have missed any of our previous lessons and really want to catch up, all our recordings are available on our website, including that lesson where we did a lot of differentiating and practicing those skills. Okay, right, here we go. Find the equation of the tangent to f of x at x equal to minus 1. Okay. Now, we're going to start, I would say, the first thing to do is just find the derivative. And even a tip for the calculus section of your paper as well is that in any of the questions, if you're stuck and you're not sure what to do, just differentiate. Differentiate will likely get you 1 or 2 marks, even if you don't go further. If you're stuck on this question about the equation to tangent, differentiate, at least will get you some marks, okay? So we're going to start by doing that. We're going to differentiate, find the derivative. This is going to give me 2 times 3 is 6x. 1 times 14 is plus 14. X to the power of 0, so we won't write that. And then minus 5 when differentiated is 0. So here's my derivative. So first step is to find the derivative. Okay, now we're going to calculate the derivative, the value of the derivative at the point where this tangent touches. Okay, so if you're writing your notes, or if you're taking screenshots, that's basically going to be our second step. Calculate the value of the derivative at x equal to minus 1, because what that gives us is the gradient of the straight line at this point. Okay, so we sub in minus 1 into our derivative, and that gives us minus 6 plus 14 is 8. Okay, so highlight things as we go, because that's going to be important, and maybe highlight that as well. Important things that you calculate as we are going. Okay, so you would have noticed that, again, we only have an x coordinate. We need a y coordinate. So we need to calculate the y coordinate. We calculate the y coordinate by subbing it into f of x. So we go f of x is minus 1. So to get our y, we sub that in. And that should give us, let's use calculator, make sure it's foolproof. Squared minus 14 minus 5. Oops. 3 minus 1. Okay, so that y coordinate is minus 16. So maybe write that down somewhere clearly as well as you're working out, so that you know, okay, so there's my point. This is the tangent point. Okay, so this is where the straight line cuts that parabola. We can also, it really helps to make a little sketch of the situation, because we have this parabola, 3x squared plus 14x minus 15, so it's a happy face parabola. That's our f of x, and at this point, minus 1 and 16, minus 1, negative 16, there's a straight line touching the parabola. Okay, and that pink line is basically the line that we are trying to find the equation on, going through this whole process. Okay, and then lastly, determine the equation. So y equals mx plus c for a straight line, as we know. So our gradient, we calculated our gradient. That's this number here, 8. So we can replace our gradient with an 8. because the value of the derivative at that point is 8. Now we still need to find what C is. For C, we are going to sub in our point, -1 and -16. So y is -16, 8x, sorry, x is actually -1. So we're just going through a process now of finding the equation of a straight line. So -16 is -8 plus c. And now we're going to add our 8 on both sides. And that is c. Therefore, final answer is y is 8x plus 8. So this pink line that I drew here, which is the tangent, that is the equation that we just found. Okay, so y is 8x plus 8. Let's go through those steps again. And more than just, the steps and trying to think what are the steps, think of the logic of it. Okay, so let's start with that situation. There is the parabola. It's got a tangent at -1 and -16. We know it's, Belinda, I'll get to your question just now. We know it is a straight line, y equals mx plus c. So we need to go through a process of finding what the gradient is and what the y-intercept is. That's where we start. You're absolutely right. It is -8. There we go. Thanks, guys. -8. There we go. Okay. We should have like a, I don't know, I wish we could hand out chocolates every time someone catches me make a mistake.
Yeah,
or a prize of some sort. Hey?
No, we'll eat them on their behalf. I'll eat them on your behalf, guys. Don't worry. I'm looking out for you guys. Thanks, by the way. Thanks.
There are some lessons, there are lots of chocolates to be handed out. Okay, so let's go through that logic again. We find the derivative. We need the derivative because we need the gradient of this pink line, okay, this straight line as it touches the point. So that's why we find the derivative, because the derivative can help us determine the gradient at any point. So we do that first. Then we substitute the x value into the derivative, which x is equal to -1, so that goes into the equation of the derivative, and we get 8. So this means at that point where x is -8, the gradient of the straight line is 8. Okay, that's what that gives us. Now, to do the rest of our straight line, we need a y-coordinate for this point that we are working with. So to get that y-coordinate, we're only given our x-coordinate, so we need a y-coordinate. So we substitute it in to f of x. Make sure you understand where you're substituting what and why. Okay, so now we want a y-coordinate, so we substitute it into f of x, not into the derivative equation. Okay, so make sure you understand that. And finally, we've now gathered everything we need to do the equation of the straight line in totality. We've got a point that we can sub in so that we can solve for c. We've got 8, which was the gradient. And we sub in our point, -1 and -16, and then c is -8, not 8. Okay. Right, everybody, let's give it a go. All right, I don't know if anyone still wants to take a screenshot of all the steps and the logic of it, because we're now going to try this one on our own. Okay, just shout if you need me to scroll back, but there's the question. Determine the equation of the tangent to the graph of f of x is equal to x squared minus x at x equal to 3. Okay, there's the question. Maybe I can move it so that we can also see maybe some of the steps. Okay, I'm going to give you till, this is normally a 5-mark question. So I'm going to give you till 17:42 to finish it, and we're going to check in, see how you're doing. Okay. 5 minutes, 17:42. Nice one, Belinda. That was very quick. Check your work, make sure that it is all correct, and we're going to start putting up the answer in about 3 minutes. Well done. Dan Colofelo and Sibusiso and Solomon, Tamika, Cassandra. Nice. Kirsten. Excellent. Hey, Ms. Kaka, I think we can go home now. Okay, you can carry on working out if you are still busy. I am going to start with the little bits and pieces. And if you are maybe stuck somewhere, let us know. DM. Praise. Good stuff. Okay. So check if you are still working things out. There's our derivative. Then we sub in x equal to 3. That gives us the 5. And if you've got 5 in your straight line equation, then you know you've done that right. Okay, now we need to find the matching y coordinate for our x coordinate. So we're going to sub that into f of x. That's going to be 3 squared minus 3. That's 9 minus 3 is 6. So our coordinate point that we are working with is 3 and 6. So again, just a quick representation of the situation. It's a happy face parabola we don't care so much about the detail, okay? We just know that this is a hyperface parabola, and there is a tangent at x equal to 3 and y is 6. So that's basically what it looks like. So no need to be specific about x-intercepts or anything like that. We can just draw a parabola that represents roughly what that parabola x squared minus x is going to look like, just for this purpose. Okay, and so we've got tangent point, we've got gradient, we've got y equals mx plus c. We replace the m with our derivative value at 3, which is 5, and then we sub in 3 and 6. So y is 6, x is 3, plus c. Subtract 15 on both sides, we get -9. Final answer, y is equal to 5x minus 9. Okay, excellent stuff. Well done. I think a lot of people got that right. That's excellent. That's 5 marks in the bag. So if you can now differentiate, you can do first principles, you can do tangents, you're already on about 15 marks for the calculus section, which is fantastic. Okay, Miss Coco, I think it is time for the quiz.